So what it does is, in the first part you need to balance like we always do, but in the second part it asks you about mass of product, okay? And to do that, we're going to be doing some stoichiometric processes. Now, the first step is balancing the equation. I'm going to write it again and we're going to balance it. So the equation is H3PO4 phosphoric acid plus calcium OH2 calcium hydroxide produce Ca3PO4 2 calcium phosphate and H2O, which is water. So what I do in the first place, I notice that calcium is 3 times, okay? So I balance calcium in the first place. Then I notice that phosphate, the iron phosphate, is twice. So I put it 2 where I have my phosphate, okay? My phosphate is there, so I'm going to put it 2 over there. And now I see the amount of hydrogens. Here I have 6 hydrogen plus, and here I have 2 times 3 hydrogens. So here I have, in total I have 12 hydrogens. So in my product I need to have 12 hydrogens. And to have 12 hydrogens I need to multiply times 6. And with this my equation is already balanced. Now you can balance as I told you. It's going to take longer, but still it's going to be balanced. Once that your equation is balanced, you have to work in the rest of the problem. It says, what mass of each product results if 750 milliliters of phosphoric acid reacts according to the equation. Okay, so they are giving me molarity. In this case, molarity is equal to 6. Okay, and they are giving me volume of solution. Okay, in this case the volume of the solution is 750 milliliters. According to the equation, to the formula that we have for molarity, we know that molarity is equal to numbers of moles of solid divided by liters of solution. So the first thing I notice is that milliliters and liters don't match. So what I have to do is I need to convert from 750 milliliters to liters. Okay? So what I do is I apply the formula for conversion. I'm gonna make the conversion process here. 750 milliliters times, in 1 liter you have 1000 milliliters. You cancel milliliters with milliliters, which gives you, as a result, 0.75 liters. Okay, so now you know the liters of the solution, and you know the molarity, and you can easily get the number of moles of solid. In this case, the solid that is in the problem is the phosphoric acid. Okay? So I say number of moles of solid, the isolation process is going to be molarity times the liters of my solution. Okay? So my molarity, I know it's 6, and my liters of solution is 0.75 liters. So how much is this? How much is this?
4.5.
4.5 moles. Okay? 4.5 moles. Now I have my number of moles. So I'm going back to my equation. I'm gonna write it again. Take a look. I write my equation again, and now I know that from my solid I have 4.5 moles. And I want to know how many grams of each product I'm going to get. To do this, I need to make an stoichiometric process. So because they're asking me grams of my product, I need the molar masses. Okay, so I need to get molar mass of this one, molar mass of calcium phosphate, and molar mass of water. So for calcium phosphate, the molar mass process, you already know it. I'm going to zoom in. Okay, to get the molar mass of calcium phosphate is calciums 1 times 2 phosphorus 2 times 4, sorry, 4 times 2 oxygens. This is how you get the molar mass of calcium phosphate. So this will be 3 times 40, 2 times 31. Make sure that it is right. I think it's 30.90 something, so 31 rounded. And here is 8 times 16. How much is this? This is 120. This is 62. And this is 128. I'm not sure how to do it. Okay, 8 times 16. Yeah, 128. So my molar mass there is 310. Did you get the same result as me?
Yes,
Yes.
And for H2O, we have 2 hydrogens and 1 oxygen. This is 2 times 1, and this is 1 times 16. So this is going to be 2 plus 16. So the molar mass is going to be 18 grams per mole. Okay, once I have the molar masses, I can get what the problem is asking me to find. Okay, I always begin with my given. Okay, so they are giving me moles of solid. So my path will be From moles, okay? From moles given, you will get the number of moles unknown. And from moles unknown, you're going to get the mass unknown by using the molar mass process. That's the path, okay? So you say 4.5 moles of phosphoric acid times. Okay, here, from moles to moles, I use molar ratio, okay? So what is my molar ratio between phosphoric acid and calcium phosphate? What is my mole ratio? How many moles of phosphoric acid the problem gives me?
2.
2. And in the unknown, I have invisible 1 mole of calcium phosphate. Okay, here you cancel moles with moles. And then with the molar mass, I can get the grams. So I say 1 mole of calcium phosphate has a molar mass 310 grams of calcium phosphate. How much is this?
697.5.
697.5 grams of calcium phosphate. And this is the first answer, okay? So from phosphoric acid, for from that amount of phosphoric acid that has a concentration of 6 molar, I can get almost 700 grams of calcium phosphate. That's quite a lot. And then I do the same process but for water. So I begin with my number of moles, and I'm going to get my grams of water. So what is my molar ratio between my phosphoric acid and water? What is my molar ratio? How many moles of phosphoric acid?
2.
How many moles of water?
6.
And then I multiply times the molar mass of water, that is 1 mole H2O, 18 grams H2O. I cancel moles of phosphoric acid and moles of water with moles of water. As a result, I get how much?
243.
243. Okay, so let me see. So as you can see, even if the topic is not so related to stoichiometry, we still can make stoichiometric processes from the amount of moles. In the end, the only process that we did here about molar concentration was in the beginning, okay, when we got the number of moles. The rest is pure stoichiometry. That is a procedure that you are familiar with. But sometimes when we move on, we tend to forget procedures that we used to do before. So that's why I wanted to explain this exercise for you to see what to do in the case that the exercise is asking you to do an stoichiometric process. In this process, where do you have doubts? Where do you have doubts? Just analyze and read carefully what every exercise gives you, okay? So here in part B, the problem gives you everything for you to find the number of moles, but that's not what the problem is asking you to do. So always analyze what is the information you have, what is the data that you manage. In that way you can tell what you get, and from what you get, you can trace a mental path to find the answer that you're actually looking for. So as a review, balance the equation, we do the balancing process, okay? It says mass of each product results. They're asking you for mass, not for number of moles. And they're asking you what mass of each product results. And they're giving you the volume. So you have to do a conversion process from milliliters to liters by dividing by 1000. And then isolating to get the number of moles of solid. I already gave you the formula for that. And from this, and ahead, okay, what you do here is pure stoichiometry. So the first part is just a concentration of solutions, and the second part is stoichiometry. Watch this video again, okay, if you have doubts on this process.